Hi students, in this video we're going to look at how to anti-differentiate exponential function. Right, so after watching this video you should be able to use the formula for integrating exponential functions. We're going to talk about, well, we've already talked about integrating sums of functions. We just integrate each one separately. We're also going to do some integration of exponentials that involve linear powers. Right, so you always remember I've been talking about anti-differentiation in the last few lessons. It's the opposite of deriving. Make sure you always have your constant of integration, and the derivative of my exponential function, e to the x, remember, is just itself. All there is to it. So we're going to use that when we do our anti-differentiation. Right, let's consider this function we've got here. We've got 4e to the 3x minus 1. Now, if we wanted to derive that function and work out what f dash was, when we have an exponential, it actually stays the same. So 3x minus 1, but we have to multiply the whole thing by the derivative of the power, which in this case is 3. So that becomes 12e to the 3x minus 1. So the key step in differentiating was multiplying by the derivative of the power. So when we consider the antiderivative, what we need to do is just apply any steps we use in deriving in reverse order with opposite operations. So if we have to find our integral, so f of x is our integral of 12e to the 3x minus 1 dx. That's, again, with our exponential, it's going to stay the same. But instead of multiplying by the derivative of our power, we're going to divide by the derivative of our power. So, and then to simplify, 12 over 3, well, that's 4, which nicely fits with the function we started off with. And this is going to be a pattern we come back to regularly. If, as a part of our deriving, we have to, well, a normal part of our deriving, using our chain rule, is multiplying by the derivative of the power. When we anti-differentiate, or when we integrate, we divide by the derivative of the power. So, deriving, we're multiplying by the derivative of the power. Integrating or anti-differentiating, we're dividing by the derivative of the power because it's the opposite operation. All right, so remember, if we've got f of x equals e to the x, then our integral f of x is just going to be the integral of e to the x, which is just itself, right? Just itself plus c. If we've got something in the power, so if we've got something like 𝑎𝑥 plus 𝑏, some linear function in the power, the integral is going to be e to the 𝑎𝑥 plus 𝑏 dx. Well, the integral of an exponential is itself, but because of this power, we have to divide by the derivative of the power. So divide by the derivative of 𝑎𝑥 plus 𝑏. Well, the derivative is just the number in front of x. In this case, it's just a. So e to the 𝑎𝑥 plus 𝑏 divided by a, whatever number that is, plus c. All right, so if we've got a couple of functions here to differentiate, so the integral of 6e to x minus x dx equals, all right, this first part is an exponential, so that'll just be itself, 6e2x, but we will divide by 2 because 2 is the derivative of my power. Yeah, that's right. And then it's not plus, it's subtract. We've got x to the 1, so plus 1 makes that x squared. Divide by the new power, add c, always add c. And then we've got, to simplify that, so that's 3e 2x minus x squared over 2 plus c. Excellent. Next one, my integral of e to the negative x plus 3x5 minus 7 dx. Again, similar to the last one. derivative of an exponential is just itself, but this time we're dividing by -1 plus 3x, power goes up by 1, divided by the new power for a power function, minus 7 power up from x0 to x1, divided by 1. Then simplify, negative x e to the x plus half x6 minus 7x plus c is my derivative for that one. Now this last one is a little bit trickier. What I'm going to do is rewrite this function as e to the power of natural log 5 times x. Now remember that natural logs and logs and exponentials are the opposite of each other. So if we consider it this way, e to the natural log 5, well, those cancel out. That just gives me a 5. And then the power x stays where it is. So this is actually the e to the natural log 5x is the same as 5 to the x. And that makes this a lot easier to derive. It even makes it a lot easier to integrate too. So if we're doing my integral of 5 to the x dx, that's the same as my integral of e to the natural log 5 x dx, which equals e to the natural log 5 x over natural log 5 plus c. Now e to the natural log 5, I might make that a little bit simpler because it looks a little bit gross there. E to the natural log 5, those cancel, so it's 5 to the x over natural log 5 plus c. Alright, so students, after watching this video, you should be able to anti-differentiate exponential functions that have linear powers.